You see this graph? This is kind of chart that keeps engineering leads and founders up at night. It is a classic sign of an AWS bill spiraling out of control, growing 20% month over month. I've seen this pattern before and it can sink entire projects. It is a collision course that can burn through a year's budget in just 3 months. But I've also seen teams do what feels impossible. Slash that bill by 90%, and today I want to show you the exact playbook they used and the steps they took, the tech they used and the tough calls they had to make to get it done. The problem. The story often starts with an email, a simple notification from AWS billing with a projected monthly spend so high. You think it has to be a typo? It isn't. For fast-moving teams, cloud speed is a superpower, but that superpower has a very literal cost. That bill isn't just a number, it is a crisis. The project's runway, once long and open, is suddenly shrinking. Fast, the fear becomes real. Cloud spend could kill the project before the team even proves its value. This is when a team has to do something drastic. They set a crazy goal. Cut the bill by 90% in 30 days. It sounds impossible, but when the alternative is a failure, there isn't another choice. And this is how it is done. The investigation phase. You can't fix when you don't understand. The first week should be dedicated to becoming a financial detective. The single most important tool for this is the AWS Cost Explorer. It is right there in your console. It is the best place to exactly where your money is going. You slice and dice the data by service, by region and by tags to map out the spending. Almost immediately, the big offenders will jump right off the page. A massive chunk of the bill is often from easy-to-compute instances and their related services. But just knowing that what isn't enough. You need to know why it is so high. This is where you uncover what a lot of growing companies find. A graveyard of forgotten resources. You will find unattached EBS volumes. Think of them as a virtual hard drive. Just sitting there collecting fees, you will find dozens of elastic IPs, which are static IP addresses that aren't connected to any running servers. Yet, you're paying for every single one. You will find test instances that were spun up weeks ago for a quick check and just left running. It is the digital version of leaving all the lights on in an empty office building. It is pure waste, and it adds up incredibly fast. Teams should methodologically go through every single region and service, make a kill list of everything that is unused, and schedule it for termination. Just by doing that, they will see an immediate significant win. The low-hanging fruit, quick wins with right sizing. After cleaning up the obvious garbage, next target is right sizing. Right sizing is simply the process of matching your server size to what it actually needs to do its job. And it is not something you do just once. It is an ongoing process. Let's be honest. Developers often over-provision resources just in case. We are all guilty of it. You're not quite sure how much CPU or memory you will need. So you pick a bigger, easier instance to be safe. The problem is that just in case costs you money. Every single hour of every single day. Using Amazon CloudWatch, you can look at the real performance of your instances over the past few weeks. You are hunting for CPU and memory usage. A good rule of thumb is simple. If an instance's peak CPU and memory never cross 40% over a 4-week period, it is a prime target for downsizing. You will find servers that are consistently humming along at 5% CPU. It is like paying for a fee to go to the grocery store. By systematically going through the entire fleet, identifying these underworked instances and downsizing them, it is often possible to cut the instance size in half, which cuts the cost in half with absolutely zero impact on performance. Another easy win is scheduling. Dev and staging environments are often running 24/7, but teams only work about 40 to 50 hours a week. By writing simple automated scripts to shut down these non-production servers on nights and weekends, you can instantly save nearly 70% on those resources. These are quick wins that build momentum. The big gamble, re-architecting for savings. The cleanup and right sizing are great, they often won't get you to a 90% reduction. To hit that number, you have to make a much bigger and honestly a much scarier change. Re-architecting a core piece of the application. I've seen a team that, when they first designed their system, followed a popular trend, a distributed microservices architecture. It was made up of several small serverless components, all managed by AWS, step functions. On paper, it was beautiful and elegant. In reality, it was a cost nightmare. The problem was twofold. First, AWS step function charges for every single state transition. Their service was performing multiple transitions for every second of data it processed. As it scaled up, the number of transitions grew exponentially, and the cost became a huge problem. Second, to pass data between their serverless function, they were using S3 for temporary storage. This created a constant, expensive stream of read and write operations that became a massive bottleneck and cost center. It turns out they weren't alone. The Amazon Price Video team ran into an almost identical issue with one of their monitoring services. They made a bold choice. They moved from a distributed microservices setup to a single, consolidated, monolithic application. The result? A staggering 90% drop in their infrastructure, inspired by their success. The team I saw did the same thing. They took all the separate pieces of their workflow, the data conversion, the analysis, the aggregation, and combined them into a single cohesive service. They deployed this new service as a container on Amazon ECS. The effect was immediate and dramatic. All that expensive data shuffling that used to happen over the network via S3 now happened instantly in memory, inside a single process. The complicated and costly orchestration from step functions were replaced by simple application logic. They didn't even have to throw away their code. They just changed how it was packaged and run. This one architectural change was responsible for the biggest chunk of their savings. It is a powerful lesson that the trendy architecture isn't always the right one for your specific workload, especially when cost is a factor. If you're finding these tips useful and want more deep dives into cloud architecture and cost savings, do me a favor, hit that subscribe button. It tells YouTube you're getting value from this, and it really helps the channel out. Locking in the savings. Smart purchasing with the architecture now lean and mean. The final step is to lock in those savings by changing how you pay for everything. Most teams start by running everything on demand, which is the most expensive way to pay for cloud resources. AWS offers commitment-based pricing that gives you huge discounts if you commit to using certain amount of compute over 1 or 3 years. The two main ways to do this are reserved instances and saving plans. Reserved instances are commitment to a very specific instance type in a specific region, while saving plans are more flexible commitment to a certain dollar amount of usage per hour. For most teams, saving plans are the simpler, more flexible choice, offering discounts up to 66%. For the team in our case study, their new consolidated service had a very stable and predictable workload, which made it a perfect fit. They analyzed their baseline usage in Cost Explorer and bought a compute saving plan to cover it. The infrastructure stayed exactly the same. The only thing that changed was the price tag, instantly cutting their core compute cost by more than half. For less predictable workloads like batch processing jobs and CI/CD runners, the answer is easy to spot instances. Spot instances let you bid on spare AWS compute capacity and can save you up to 90% compared to on-demand price. The catch? AWS can take those instances back with just a 2-minute warning. This makes them perfect for any job that can be stopped and restarted without causing a problem. By moving their CI/CD pipeline to spot instances, the team crushed their cost of their development tooling. The cultural thing, staying lean for the long haul, slashing a bill by 90% is a massive win. But the job isn't over. A one-time cleanup is great, but true cost optimization is about building a culture where everyone on the team thinks about cost. It is an ongoing process, not a one-and-done project. First, you need to set up AWS budgets. This is a critical tool that lets you set spending limits and get alerts when you are projected to go over. It is the early warning system to make sure you are never surprised by a giant bill again. Second, roll out a mandatory tagging policy. Every single resource launched in the account should be tagged with a project and the owner responsible for it. This gives perfect visibility in Cost Explorer and make sure your every dollar spent has an owner. Finally, and most importantly, make cost a regular part of engineering conversations. Give developer visibility into the cost of the service they are running. Start including cost analysis in architecture reviews. The point is never to blame people for spending money, but to empower every single engineer to make cost-conscious decisions. That cultural change is what keeps the team lean and efficient as they grow. 30 days after that stomach-dropping email, the team looked at the AWS billing dashboard again. The terrifying upward spike was gone. In its place was a flat line, 90% lower than its peak. They had actually done it. They saved the project budget and gave themselves the breathing room they needed to succeed. This journey is never easy. It forces the team to be detectives, hunting down every dollar of waste in their account. It requires them to be decisive, grabbing the low-hanging fruit like right-sizing and scheduling. It forces them to be bold, making a scary but necessary architecture change that ended up having the biggest impact. And finally, it requires discipline, using smarter purchasing options and building a real culture of cost awareness. The biggest lesson in all of this is that you are in control of your cloud bill. It doesn't have to be some mysterious number that shows up once a month. With the right tools, the right strategies, and the right mindset, any team can take back control, eliminate waste, and build applications that are not just powerful, but also cost-effective. I hope the story gives you some ideas and the confidence to tackle your own AWS bill. I've linked another video right here that goes deeper into savings plan versus reserved instances, and I want to hear from you. What is the biggest AWS cost surprise you've ever had? Let me know down in the comments. Thanks for watching.